So, good morning, students. This is our first class. In our first class, we are going to start the current electricity chapter. And in our current electricity chapter, we have two. In our current electricity unit, we have two chapters. One is Ohm's law, another is measurement of electric current and voltage as well as resistance. In current electricity, we have Ohm's law, Kirchhoff's law, different kind of combination of resistances, potential difference, and relation of with EMF. What is the relation between the drift velocity, current density? All these things are included in this chapter. So before starting this chapter, I am trying to say one thing. What is electric current? Say the charge is moving through a particular wire. You have a conductor. Through this conductor, the charge is moving with respect to time. The flow of charge with respect to time, or the rate of flow of charge with respect to time, is called electric current. So the first question will be, define electric current. Define electric current. So what will be the definition? The rate of flow of charge is called electric current. The rate of flow of charge is called electric current. Now, what is the unit and dimension of it? So according to the definition, the rate of flow of charge is called current. There is a current I equal to Q by T. There is charge by time. So unit will be, this is, Coulomb. And this is time. It is Coulomb per second. So unit of charge electric current is Coulomb per second. What is the dimension now? Dimension will be, you can write as A. You can write as A. I can be written as A, or you can write also I, capital I. This is the dimension of current. This is a fundamental quantity. Now, this is the fundamental quantity. That's why just by A within third bracket, you may give the third bracket or you may not. This is the dimension of electric current. Now, the question is whether electric current is scalar or vector. Whenever we are doing any kind of diagram, or we are drawing any kind of diagram, say wire is there and arrow sign is given, current is flowing through it, whether the current is scalar or vector. Okay, Subhrajit. So since the current is not obeying the vector laws, scalar. Whenever the quantities are obeying, those quantities having vector, they're having direction, those quantities having a direction, and side by side they are also obeying the laws of vector, distributive law, associative law. All the vector laws should be followed by them. But in case of current electricity, the laws are not obeyed. That's why current electricity will not going to be a vector quantity. You may ask us, how they are not, it is not obeying the vector laws? Because whenever a wire is there, current is flowing through this. Another wire is there, current is flowing in this way. You cannot consider that this current is I1, this current is I2, and resultant current will be along this. You cannot do that. Because if somebody is standing here, he is not getting any shock. One current is along this, another current is along this, and third current, if we consider that yes, resultant of this I1 and I2 will be along this is I3. No, there is actually no current along the third direction, this one. That's why It is not obeying. We are not able to calculate the resultant of two currents flowing in a particular direction. But in case of forces, if this is force and this is another force, and somebody is standing here, then the resultant force will act on him. That person will be affected by these two forces. That means if two forces are acting at a single point, then they should have a particular resultant. But in case of current, we are not getting such kind of resultant. That's why electric current is not a vector quantity. It is still now a scalar quantity. Further classes or for the higher level studies, we will think another way. Now, second question. Second question, you write down. State Ohm's law. State Ohm's law. Explain it. Definitely about electricity we are talking. Ohm's law about electricity, electric current. The law states that in class 10 already we have done, but in class 12 still it is included in our syllabus. So we are more or less discussing this one. Say you have a wire and current is flowing through it. If current is flowing from A to B, for any reason, current is flowing from A to B for any reason. I am not going to discuss just now what the reason to flow the current. For which reason current is flowing through it. I am not discussing this one. So, if current is flowing through it, then according to Ohm's law, the law states that if the temperature and other physical quantities remain constant, if the temperature and other physical quantities remain constant, for which? For this wire, for the surrounding. If the temperature of the surrounding as well as the temperature of the conductor is remain constant, then the current flows through the conductor is directly proportional to the potential difference between the two ends of the conductor. Potential difference between the two ends of the conductor. That means I proportional to V. So whenever there is a potential difference, there will be a flow of current. So without the potential difference, there will be no flow of current. Say this is a water lab. Say a lake is there. There is a this is the level of water in the lake. Suddenly, by any means, if there is a difference, you are able to make a difference between the two levels. The level of water is this, and by somehow you just make a difference of this level, then there will be a flow of water from this level to that level, from this zone to that zone, from this point to that point. Why? Because there is a level, there is a difference of level between the water. This is the reason why water current is flowing from higher level to the lower level. So if current is flowing from one point to another point, there must be a difference of, in case of water, there will be height of water. In case of current, there should be a difference of voltage. So if in between the 2 points, there is a difference in voltage, then there will be a flow of current. This was stated by Ohm's. According to him, the law states that in that way, if temperature and other physical quantities, remain constant, then flow of current through a conductor is directly proportional to the potential difference between the two ends of the conductor. Now remove the proportional relation, it will be V A constant will be there. Here the constant appears as 1 by R. Therefore, V equal to IR. This is the equation of Ohm's law. This is the equation of Ohm's law, where capital R equal to resistance of the wire. Now you may ask, what is resistance? Then resistance is actually capital R equal to V by I. So you may define the resistance in that way. What is resistance? The mathematical definition you can explain in this way, that the ratio of the potential difference across the two ends of a conductor, ratio of the potential difference across the two ends of the conductor and the current flowing through it is called the resistance of that conductor, of that substance. That means a ratio of the potential difference between the two ends of a conductor and the current flowing through it is called the resistance of that substance, of that conductor, of that object. Now, actually, what is resistance? Resistance is one kind of opposition. Whenever we are walking through a road, there may be different kinds of opposition. Cars are moving, running, people are walking, so we have to give side to them. Then if the road is narrow, then it will be very tough to us to cross the road. This kind of opposition during our walking is called one kind of resistance. In case of current, the opposition is offered by the charged particles. Yes, very good, Shorodip. Opposition is offered by the charged particles. Say electrons are forced to move from this zone to that zone, but in the wire there are huge number of charged particles. They are also trying to move. Whenever electrons are trying to move, huge trillion numbers of electrons, they are colliding with each other. Some electrons are moving in this way, some electrons are moving in that way. The motion of the electrons, the motion of the charges will be disturbed. The disturbed occurred in this during their motion is called resistance. So resistance is one kind of obstacle against the flow of current, against the flow of electrons or charged particles. Now, if you are asked, number 3, on which factors resistance of the resistance of a conductor depend? Resistance of a conductor depend on which factors? Now, if somebody asks you on which factors the resistance of a conductor depend, now question is that there are so many factors. Say you have a wire. This is the wire. Every wire looks like a cylinder. Every wire looks like a cylinder, is not it? This is another wire. So whenever current is flowing through wire, I think it is very much comfortable to realize to all of you that through which wire charges will move easily. The wire having a large cross section will allow the charges to flow through them very comfortably. Now, problem is that through which wire the resistance will be maximum. Through which wire the resistance will offered by the wire will be maximum. Definitely by the wire having lower cross section, small cross section. The wire having small cross section will offer low resistance. Thin wire, very good, very good. So through this wire current will flow easily. and through the wire having less cross section, current will flow in a less comfortable way. So if the wire is like this, it is very tough to flow through this wire. That means resistance of this wire will be highest, resistance of this wire slightly less, resistance offered by this wire will be least. Okay, so resistance depends on number one, cross section. Number two, length of the wire. Cross section you can denote by capital A, length you can denote by small l. Therefore, resistance is directly proportional to resistance is directly proportional to 1 by A. Again, resistance is directly proportional to L. If you combine the two relations, then it will be L by A. And in case of proportional relation, you have to introduce a constant, which already you know, all these things I know. This is capital R equal to rho into L by A. So rho is a constant, it is called resistivity. It is called resistivity. This is also a constant for a particular material or particular type of substance. So what is resistivity? Next question. So from this expression, you come to know about that resistance capital R equal to rho into L by A. If L increases, the resistance will increase. If L decreases, if capital A increases, resistance will decrease. Capital A, whenever will increase, resistance will decrease. Capital L, whenever increase, resistance will increase. So these are the factors on which resistance of a conductor depend. Now the fourth question, what is resistivity? What is resistivity? So resistivity is a constant for a particular material. Resistivity is a constant for a particular material, and it can be defined as the resistance offered by a cube against the flow of current through it when the length of each side of the cube is unit amount. I'm telling again, resistivity is one kind of resistance. This is fixed for a particular material, and it can be defined as the resistance offered by a cubical block having unit length when current flows from one phase to the opposite phase. Whenever current is flowing through a cubical block having unit length of each side, then from one phase to another phase, against the flow of current, whatever the resistance is offered by the cube, that value of resistance is called resistivity of that material. If it is made of iron, then it will be the resistance of iron, resistivity of iron. If it is made of copper, then it will be the resistivity of copper. Now, as we are telling here, iron, copper, I am telling another thing, that iron has a very good resistance. Iron has a very good resistance. Iron can apply a very good resistance to against the flow of current. But copper is such a material. Copper is such a metal which has a very poor value of resistance. Clear? Now, a copper having a very poor value of resistance as well as a resistivity, it can be used as a conducting wire. In our laboratory, if you going to do the experiments, electrical experiments, then you will observe that so many wires are there which are used to connect from this part to that part, this part to this that part. I have also done one experiment in a laboratory also regarding the current electricity, and in that experiment I have shown that so many wires are there. We are using to connect the 2 points. All these wires are made of copper because copper has very poor resistivity. Okay, so that is a very good good conductor. It is a conductor having very poor resistance. That's why copper is using as a connecting wire. Okay, next, number 5. What is electric current density? Say, as I am discussing still now, current is flowing through the different types of wire. Current is flowing through different defined electric current density. What is this? As you have such kind of wire, and you know everywhere looks like cylinder. So whenever the current is flowing through the wire, having cross section something, say A, and the flow of current is say I, then that kind of wire carrying current I through the cross section capital A can be termed in another way, that is I current is flowing through the cross section A. I current is flowing through the cross section A. Now, what is current density? Per unit area, whatever the current is, per unit area, whatever the current is flowing, this is termed as J. From cross section A, unit current is flowing. Per unit cross section, whatever the current is flowing, that is termed as current density. That is termed as current density. Very important. Now, this current density can be termed again as J. This current density is a vector quantity. This area of cross section is also vector quantity. You can also write in that way. They are the dot product. The current is the dot product of current density and area of cross section. As you know, area is still not a scalar quantity. In earlier classes, you have discussed with the teacher that in books there are also such kind of discussion that area is scalar. But now the area is not a scalar still now. So this is the area, capital A. It is also vector. And what is the direction of that? The perpendicular to this plane is the direction of this. Perpendicular to this plane is the direction of this. If this is the area, then it will be the direction of this area. If this is the area, then it will be the direction of this area. So area is not a scalar now. This is a vector quantity. Dishan, you mute your microphone. Dishan, are you hear me? Are you able to hear me? Now, so what is the unit of current density? It is ampere. It is meter square. So ampere per meter square. Ampere per meter square. You can write ampere per centimeter square also. So what is the current density? How you can define current density? Current density is the current flowing per unit area. Current density is defined as the current flowing per unit area of a wire of a conductor. Current flowing per unit area of a conductor. Unit, what will be the unit? It is a ampere per meter square. What is the dimension? You know, dimension J equal to I by A. I is a fundamental quantity. So you can write I as I. And A means area, L square, it will be L to the minus 2. That is I L to the minus 2 is the dimension of current density. So current density is a vector quantity. It is denoted as J equal to I by A, and I can be expressed as vector J dot vector A. Clear? Now the new topic, define drift velocity. What do you mean by drift velocity? Define drift. Velocity. Define drift velocity. The word drift means shifted. Drifted. When a drift means from some particular point, you are gradually sliding yourself or sliding something is called drifted. Now, if you have a conductor, and you know in a conductor there is enormous number of electrons, ions are there. These ions are randomly in motion. If you have a conductor like this, it looks very simple, but it consists of huge trillion numbers of electrons, ions. They are randomly in motion. In every direction, they will move in a normal way, in room temperature. But if you apply a potential difference across the two ends of the conductor, or just you connect a cell across the two ends of the conductor, now all the electrons inside the conductor, all the electrons, what they will do? They will try to move in a particular direction. They will try to move in a particular direction. Say, this electron, that electron, this electron. Maximum of the electrons will try to move towards the positive pole of the cell. So, in case of application of external field by connecting a battery or a cell across the two ends of a conductor, the electrons or ions, those which are randomly in motion, those who are moving in a random manner previously, now they will try to move in a particular direction. This new velocity achieved by the electrons are slightly different from the previous velocity. Previously, they don't have any kind of particular direction. They are randomly in motion. They have a random motion. Then now they are moving in a particular direction. All the electrons will try to move towards the positive ion or positive pole. All the positive ions try to move towards the negative pole. This kind of new velocity developed in the electrons or ions due to the application of the external field or external force is called drift velocity. All the electrons and ions are now drifted. They are trying to move in a particular direction. This velocity is called drift velocity. Say the charge of electron is E. The EMF of the cell is capital E. So field developed across the, say, or you may consider that voltage of the battery is V. If the voltage of the battery is V, the field will develop inside the conductor. A field will develop inside the conductor. What is that field? That field E equal to V divided by L. If the length of the wire is L, then it will be L. Now, force on each electron due to this field F equal to, EE. Force on each electron due to this external field is EE. Now, from the equation of motion, that is, we have a V equal to U plus AT formula. If you are interested to find the velocity after time, after a few seconds, few moments, what is the new velocity? Now the particle should have a zero velocity because it is not moving in a particular direction. It is moving in this way, again it is moving that way, it is moving in this way, again it is moving that way. Average velocity of it will be zero. But whenever the field is applied across the two ends, it should have a particular velocity. That velocity, just I termed it at Vd. I denoted it by Vd. Vd. D means drift. Now, initially, there is no velocity. The average velocity is zero. Now, suddenly, there will be an acceleration due to the external force. And what is the value of the force? It is an acceleration equal to force by mass. Force equal to EE. And whenever the electrons are moving, the motion is not a smooth one. This motion will not be a smooth velocity, because whenever the electron is moving, it will collide with a particular electron. Again, it will collide with another electron. Again, it will collide with another electron. Always they will be in random collision. After that, they will try to move. The time difference between two successive collisions, electron is moving, after a particular motion of a particular path, it will collide with another electron. Somehow it managed the motion. Again, it starts its motion. Again, it collides with another electron. The time difference between the two successive collision of electrons, the time difference between the two successive collisions of electron is called relaxation time. It's called relaxation time. The time difference between two successive collision is called relaxation time. That means in this, between the two collisions, the electron was in relaxed mode. That is called a relaxation. That is termed as tau. So Vd equal to, F equal to E by M into tau. But if you give a vector, therefore in vector form, no need to therefore, in vector form, the Vd can be termed as V suffix T. And you see the electric field is from positive to negative in this way, but electrons are moving in opposite way. Electrons are moving in opposite way. That's why Vd and E are opposite, and a minus sign should be introduced here to make a realization that Vd and E are not in same direction. You can also say that there is a charge electron which is a negative, which is considered as negative one. That is why a negative sign is introduced. So this will be the expression of the drift velocity Vd vector equal to minus EE vector by m into tau. So what is the expression of Vd? E minus E by m into tau. What is the relation between Vd and E? They are opposite. Vd is one direction, in one direction, E is in opposite direction. So what is drift velocity is clear to everyone. And what about the expression of drift velocity? What is relaxation time? You may be asked, what is relaxation time? The time difference between two successive collision. of electron. The time difference between two successive collision of electrons is called a relaxation time. Okay, I think all of you are able to realize this. After the class, at the end of the class, I will try to take the feedback from your side, and as well as I will take the attendance also. So listen very sincerely. So still now, what we have done? We have done what is current electricity. What is Ohm's law, state Ohm's law? What is resistance? On which factor resistance depend? What is resistivity? What is resistivity? What is the unit unit of unit we missed it. Okay, leave it. And after that, what is drift velocity? What is current density? What is the unit and dimension of current density? Okay, so drift velocity was one of the most important point or question of this chapter. Yeah, it is given randomly, and in many cases it is asked that define drift velocity, find out the expression of it. 1 plus 2. Okay, 1 plus 2. Now let us discuss the number 6 question. Number 6. Now, still now we have discussed that what is resistance and drift velocity. After the class, Shanubhav, let me finish the class. After the class, I will try to remove all of your queries. I will try to repeat the queries you have. Okay, just listen. So it will be number 7. Thank you. Let me finish the class first. After the class, if you have any kind of query, then you may ask, because some of the students are already realized this. Again, if I repeat it, it will be boring for them also. Now, number 7. Now, we have discussed Ohm's law. Ohm's law means current is flowing, that current is directly proportional to the potential difference. But in every cases, Ohm's law is not applicable. In all types of substances, Ohm's law is not applicable. There are so many restrictions, so many limitations of Ohm's law. Limitations of Ohm's law. Limitations of Ohm's law. So according to Ohm's law, one experiment we have done in the class, that is a verification of Ohm's law, or we have drawn a graph between potential difference versus current. In that case, we have just observed that if you are applying potential difference across the two ends of a conductor, then the current flowing through it changes in that way. That means if the current is this, voltage difference is. If the current is this, voltage difference will be this one. If we change the voltage difference, then current will also increase. The straight line indicates that voltage and current are directly proportional to each other. But some substances, some materials are there, those are not following this type of relation between current and voltage. Say in case of carbon, in case of semiconductor devices, semiconductor substances, in case of gallium arsenide, like this, those are semiconductor product compound. They are not obeying the linear proportional relation, linear relation between the voltage and current. In case of a diode, if you observe, in our syllabus we have the experiment. We'll try to do the experiment in if the school will going to be open in coming days. In case of diode, the relation between the voltage and current is like this. So this is the voltage and this is the current. This is the relation between the voltage and current in case of diode. Okay, so sometimes it is observed that it's like this also. So this kind of substances are not obeying Ohm's law. So what are the limitations of Ohm's law? In case of substances not obeying the linear relation between the current and voltage are called the non-ohmic substances. Those substances not obeying the linear relation between the voltage and current are called non-ohmic substances. Yes, very good. Somebody asked you Guho, Diptanu Guho, someone. In this case, the resistance you see here. In this case, V by I, always constant. Shanubhab Guha, very good. Shanubhab, you just point out the matter correctly that in this case, the voltage and current are not linear. So whenever you will take this point and that point, the slope will be different. Here the slope is this. So this is voltage and this is current. The ratio of voltage and current will be, in this case, here this is current and this is voltage. Slope will be different. So this is actually voltage and this is current. If you take the V by I ratio, that means you are getting the slope, that is tan theta equal to V by I. What the tan theta is giving? Resistance. In case of IV graph, if you consider the slope tan theta, that tan theta will give you the resistance of that conductor through which you are flowing the current or you are passing the current. So in case of conductor having such type of linear relation, their resistances are constant. These are called ohmic substances. Those substances in which the VI relation is not constant, VI relation is not a linear relation. There is a curvilinear or different kind of path followed by them. That in those substances, the resistance always in a varying mode. These resistances or these substances are called non-ohmic substances, and resistances are called dynamic resistances. The resistances of those substances are called dynamic resistances. So what is dynamic resistance? The resistance of a substance whose value continuously changes with the application of the external potential difference, with the application of the external field, are called dynamic resistance of those substances. The resistance of those substances are called dynamic resistance. And the substances are called non-ohmic substances. All semiconductors, silicon, germanium, or semiconductor compounds, carbon, these are non-ohmic substances. These are non-ohmic substances. Clear? So, in many cases, you may be asked, write the name of two non-ohmic substances. You can say carbon, you can say semiconductor substances, like that. And all the metals, all the conductors, they are silicon, you can also say. All the conductors are called ohmic substances. Copper, iron, aluminum, nickel, all these. Clear? Now, internal resistance. What is internal resistance? What is internal resistance of a cell? On which factors? It depends. On which factors it depends? Yeah, on which factors it depends? Say any kind of cell, it should have two electrodes, cathode and anode. So current is flowing from one electrode to another one. Now, say you have a resistance and you have a cell like this. Whenever from the cell current is flowing, the current will complete the path. Whenever it will move from, current will try to move from negative pole to positive pole through the cell will offer a particular value of resistance to it. The resistance offered by the cell, whenever the current is flowing from one electrode to another, is called internal resistance. I'm telling again, the resistance offered by a cell during in between the two electrodes of the cell, the resistance offered by the two by the materials or substances between the two electrodes of a cell is called internal resistance. Internal, that is the matter of the inside phenomenon. This is the phenomenon of inside. So whenever the current is flowing from one electrode to another electrode inside the cell, the resistance offered by it is called internal resistance. It is denoted by small r. So if you have the EMF of this cell is E, and internal resistance is denoted by small r, current is denoted by I, then E can be written as IR plus I small r. I capital R plus I small r. This I capital R is the voltage drop across this external resistance. It may be a bulb. It may be a bulb. It may be a fan. It may be an electrical devices. So whenever any instrument or electrical device is connected, it will behave like a resistance. So that voltage drop across that device, the voltage drop across that device or resistance is termed as V, and E equal to V plus IR. That is the EMF of a cell equal to the potential drop across the two ends of the conductor plus the voltage drop across in between the two electrodes. It is IR. So what about IR? It is E minus V. And what about R? It is E minus V by I. Clear? It is E minus V by I. So internal resistance is equal to EMF minus potential difference divided by current. Now question is that on which factors it depends? On which factors it depends? One thing I'm trying to show you that if you try to design a cell in lower classes, already you may observe this kind of diagram. Say this is the liquid that is we are calling electrolyte, and if you have such kind of electrode here, another electrode is there, then this is the external resistance, and current is flowing in this way. Okay, so current is flowing in this way. This is positive, this is negative. Whenever electrons, I'm just considering the electrons. Now electrons are in motion through the wire, or positive ions are moving in this way, whatever. In this case, the electron or ions can flow through this wire in a very easy manner. There will be no problem. Minimum amount of resistance will be offered by the conductor, because the conductor is a good path for the flow of charge. But inside the electrolyte, this is not a very good conductor, like this metal. Whenever ions and electrons are trying to flow from this electrode to that electrode through the electrolyte, then that electrolyte will offer a resistance. The motion of the electrons, the motion of the ions will depend on the nature of the electrolyte, how much comfortable they are to carry out the electrons through it. That is called resistance, and it is here inside of the conductor, inside of the cell, that is called internal resistance. So what is internal resistance? Internal resistance is the resistance of what between by the electrolyte or the substances inside the cell. On which factor it depends? Number one factor, nature of the electrolyte. Number two, area of the plate of the electrode. Area of the plate of the electrode. Number three, distance between the electrodes. If the distance is much more, that means the electrons you have to move, travel from this part to that part. There will be a big resistance. If the distance is less, there will be a small resistance. So these are the three major factors. One is nature of the electrolyte, another is area of the electrolyte, and third one is distance between the two electrodes. These are the main factors. Clear? So 8 questions till now we have discussed. Now I want to give one numerical on the basis of this. Write down one numerical. Numerical on current electricity. Number one. If 2 ampere current is flowing, if 2 ampere current is flowing through a wire of area of cross section 0.2 centimeter square, then find out the current density Very simple problem. Just now we have discussed the formula. We know current density J equal to I by A. Here I is given as 2 ampere, and area of cross section is 0.2 centimeter square. If you try to convert it into meter square, then it will be 1 centimeter. Whenever convert into meter, it will be -2. Then it will be -4. Very good. So 2 divided by 0.2, 10 to the power plus 4 ampere per meter square. You have to write the unit here also, ampere per meter square. So it will be 10 to the power 5 ampere per meter square. Big value of current density. This simple formula you may given 10 to the power 5 ampere per meter square. Number 2, I'm giving another one. Number 2. Find out the internal resistance of the cell. Find out the internal resistance of the cell. This is 4 ohm resistance. This is 12 volt, 2 ohm internal resistance. Sorry, there is no 12 volt. 0.2 ampere current is flowing through the wire. Now you are asked to find the internal resistance of this cell. How you can find? The formula is very simple. There is a small r equal to E minus V divided by I. Okay, E minus V divided by I. Now, as the current is flowing, E is given as 12, V will be 4 into 0.2. That is 4 into 0.2 and divided by I equal to 0.2. This is at ohm. The 12 is the EMF. This is 0.8 divided by 0.2 and what will be the value? It will be 11.2 divided by 0.2 ohm. You just convert it. It is a 2 ampere current. Yes, just make it a correction. Make it 2 ampere current. Then this problem is also correct. If you give it a 2 ampere, then it will be realistic. Then it will be 2 ampere. It will be 2 ampere. 8. It will be 4 divided by 2. So it will be 4 divided by 2 ohm. Am I right? 2 ohm. Therefore, why I am changing this one? Actually, internal resistance is very small quantity of resistance. Well, by mistake, I have given the current is a 4 1. The current is 1 over 12 volt battery is there, 4 ampere resistance is there. Current should be higher one, not like 2.2 ampere. So internal resistance of the cell is 2 ohm. Internal resistance of the cell is 2 ohm. Clear? Such kind of problem may be given in exam. You may be given the internal resistance also, and you may ask to find the current in the cell. Okay. So still now what we have done, I think all of you can realize, all of you are able to realize. So let me ask 3 questions from this. Let's check how much you are able to realize all these things. First one, those who are able to ask, give the answer, just raise your hand. Those who are able to answer it, just raise your hand. Don't speak at a time. Number 1. Whether the expression I have written is a correct one or wrong. Anyone? Okay. Ananya, you can say. You're the first. Suprabhutim, you are wrong. Jafrin, wrong. Udayan, correct. Very good. Whether the expression is correct. Ananya Kumari. Rohit, no. Saptajuti, correct. Rohan, you tell me.
So the expression is wrong because I is a scalar quantity.
Yes. I think your answer is not correct. I am just telling you whether I have written the expression is the correct one. Anyone, Udayan?
Sir, J vector dot. Sir, J vector dot A vector dot.
Yes. Suprabhutim, na? Very good. So it will be J vector dot. I have missed this one. If vector sign is given, but there is no sign here, Whether it should be like this or it should be like that. Any kind of sign you have to given in between the two physical quantities. I have written without this. So this is not a correct expression. You cannot write in that way. You should write in this. This is a correct expression. Very good. So some of you are able to answer it, some of you are not. Next, second question. Internal resistance. Internal resistance depends on the nature of the electrolyte. Is it correct or wrong? It depends on nature of the electrolyte. Correct or wrong? Lokojit, you tell me. Internal resistance depends on nature of the electrolyte. Is correct or wrong? Shumit. Okay. Maximum of you are able to give the answer. Yes. It depends a little bit to the nature of the electrolyte. But other three factors on which it depends. Just tell me, Lokojit, on which factors it depends? What are the other three factors? Just now we have discussed. Shanubhav, you tell me. Lokojit is not able to answer. Who can tell me? Rohan, Tarin?
Sir, area of the plates and the distance between the plates.
Area of the plates, number one. Number two?
Distance between the two plates.
Distance between the two plates. Very good. Number three?
Nature of the electrolyte.
Nature of the electrolyte. Right. Very good. Jeffrey, you are also correct. I have seen your answer. So, Lokojit, I am expecting it from your side. What are the other factors? Last question. Number three. Just can anyone tell me rho? You know the rho resistivity. Rho is a constant or variable quantity?
Constant.
Constant. Rho is a constant for a particular material. Is there any scope to change the value of rho for any circumstances? Whether we are able to change the value of rho of a substance, of a metal, through any circumstances. Anyone can answer it? Dipendu. You are telling that yes. Then how? Dipendu. Okay. Rohan Bal.
By increasing or decreasing the area of cross section, length, etc.
No. That is the very common conception we have. We are thinking in that way. Okay, fine. Your conception is okay, it is natural. If we change the cross section, the resistance will decrease. This is actually the property of a metal. This is actually the property of a metal substance. It cannot be changed easily. But if the temperature is increased tremendously, to some extent, say 120, 120, 130, 150 degrees centigrade, not like a 10, 12, 15 degrees centigrade. This is more than 100, something like that. Then resistivity may change. But it is very tough to change the resistivity. In normal temperature, resistivity will not going to be changed. It is constant. But if you change the temperature to some extent, large extent, then there may be change in the resistivity. Am I clear? So these are the today's discussion regarding our first class through online mode on current electricity. Okay. In our next class, the rest of the discussion will continue. Till now, what we have done, all of you should prepare in your copy. You should keep it with your copy. And after that, after whenever we are able to join the offline classes in school, you must submit. You must submit the copy. Especially I am talking about my subject. Regarding the physics copy, all of you should submit the copy in a proper way after whenever we are able to join the school. Okay. Shanubha, what you are telling? Drift velocity. Okay. Drift velocity. Shanubha has a confusion regarding this. Say you have a wire. And in this wire, all the electrons are moving randomly here and there. All these, in all directions, electrons are moving randomly. There is no particular way, there is no particular direction of the electrons to move. But all the electrons has a motion. If you connect a cell across the two ends of the conductor, then the electrons will be in motion towards the positive pole of the cell. They will try to move. They will try to move in a particular direction as there is an external field is applied across the two ends of the conductor by connecting a battery or cell. In this case, the new velocity adopted by the electrons due to the application of the external force by connecting a cell is called drift velocity. This is the new velocity. Compared to the previous condition, this velocity has a particular direction. Electrons or ions are moving in a particular way. That velocity is called drift velocity, which is expressed as, who can tell me? Who can tell me? Apshana, Atanu, Chandrima. Anyone can? Dibbendu, you tell me. What was the expression of drift velocity?
Minus small e capital E vector by m into tau.
Shubhra Pratim, whether this expression is correct? Whether this expression is correct? Shubhra Pratim, Udayan, Ananda, Ambika. No. Very good. So how I can make it correct? Anyone can?
Sir, VD উপর vector দিয়ে দিলে।
Yes, there should be a vector sign. As just before few minutes I have discussed that if we express it in vector form, the left side and right side, both should have the same nature. Otherwise, you cannot write some mangoes equal to some bananas. There are some mangoes equal to there are some bananas. You cannot write like this. Because if there is an equal to sign in left side and right side, both the physical quantities should be the same nature. Both the physical quantities should be the same nature. So here, if it is a vector, then it should be a vector. Vector not equal to a scalar. Vector should be equal to some vector. That's why the VG vector equal to minus E by m. Why the minus sign is minus? What is the significance of minus sign? Anyone can?
So opposite direction.
In between what and what? Opposite direction? Davojyoti, Dibbendu. Opposite direction of what? Opposite direction in between drift velocity and electric field, because electrons are moving in this way and electric field is in opposite direction. Say electrons are moving in this way and electric field is in between this opposite direction. So the motion of the electron and field are in opposite direction. That's why minus sign is there, which indicates that this and this are not in the same direction. Clear? Anything else from your side? If anyone has any kind of query regarding today's class, you may ask. Okay. Okay. Sure. Then, okay. Since you don't have any kind of query, you are leaving. So in next class, we will discuss the rest of the discussion. So till now, what we have done, I hope all of you will be able to prepare a note and keep the note with you till the school is opening.